reactivity series and its applications. We have basically sorted out a reactivity series for a purpose, and the purpose is to see different applications of it, because plenty of metals are involved in plenty of daily life reactions or industrial reactions and all that, and reactivity series has its applications. So a position of the metal in the reactivity series has a meaning, okay, like displacement reactions, one application. The word displace mean a metal which is more reactive will displace a metal which is less reactive from its compound. A metal which is more reactive mean which is present higher in the reactivity series will displace a metal lower in the reactivity series from its compounds. Okay, like if it is copper sulfate solution, copper sulfate, it means it is a compound of copper. Copper is in 2+ state, copper sulfate, because sulfate stays 2-. But when you add in zinc metal, a zinc rod, a zinc strip, amazing thing happens. What? You will notice reddish pink deposit of copper atoms, copper metal at the surface of the zinc. Zinc start dissolving and copper ions from the solutions are exhausting. That's why the blue color fades. Blue color fades gradually, and you find out that a displacement reaction has taken place. Might is right, more reactive is displaced, less reactive from its compound. Okay, look at the chemical equation describing it. It is zinc metal, chemical equation describing the chemical reaction. Zinc as a reactant, copper sulfate as a reactant. Now look at more reactive metal has displaced less from its solution. Zinc sulfate has formed along with copper metal. Now copper compound, it is zinc compound now, and copper has come back to the original form. So more reactive has displaced less reactive from its compound. And you can even notice the charges, zinc original form, no oxidation state, no charge, but here copper has 2+, since sulfate has 2-, zinc has 2+, sulfate has 2-, and copper come back in the original form. More reactive will always displace less reactive from its compound. Okay, reason, more reactive has more tendency to what? To lose electron, and to lose electron means more reactive, more electropositive, has more tendency to give electrons. That's why it's more reactive. And the one which is less reactive wants to gain electron back, want to stay in the original form, unreacted form. It means the more reactive is always going to lose electron and oxidize itself, and less reactive basically will going to accept electron and reduce itself. So it is a better reducing agent since it has oxidized itself, and it's a better oxidizing agent because it has reduced itself. So we notice that displacement reaction is also a kind of redox reaction. Remember, displacement reaction is also a kind of redox reaction. More reactive, displace less. You'll observe something like copper, since copper sulfate is blue in color, zinc sulfate, zinc is not a transition element, zinc is fake, it's not transition element, normally people take it. So zinc compounds are colorless. That's why solution has changed color from blue solution to colorless. Fine, okay. Even you can notice the ionic equation, since sulfate has undergone no change in its charge on both sides, 2-, 2-. So it is merely a spectator ion. The competition then stays between copper ions and zinc metal, zinc ions and copper metal. That is net ionic equation. So observations are color changes, blue to colorless, reddish pink deposit seen at what? At the zinc metal. Many a time an examiner may ask that he will give you a situation that a metal is there outside and then a solution of another metal is there, and you immerse that metal into it, and he says deposit seen, reaction took place. Straight away you will notice that if deposit seen or reaction took place, it means the metal that has been added from external source is more reactive than the one which is in the solution form. So more reactive will displace the less reactive. If he asks you to make a reactivity series based on certain observation, always notice more reactive will displace less reactive. The signs will be reaction took place, deposit seen. But if the sign is you add a metal from external source and nothing happens, it means there will be no reaction taking place. Okay, it means the metal you have added is less reactive, and the one which is more reactive will be least bothered about any external addition. Okay, so deposit seen, in this case red pink because copper is red pink, and displacement reactions are always exothermic, and that is the reason beaker gets warm. We'll see an application, another very useful application of it in the form of thermite reaction, where the displacement reaction has taken place and so much heat is released. Okay, so let's see thermite reaction.